Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have discussed about the structural isomerism, but here we are going to specifically talk about the geometrical isomerism by the metal complex but with a coordination number of 4. So what is the concept behind this? This is what I'm going to talk about in this topic. So friends, I'm going to talk about the geometrical isomerism in the metal complex with a coordination number of 4. So in that case, let me tell you that is the geometrical isomerisms are those isomerisms where we can find that is cis isomer and trans isomer. So based on that, when we are talking about a metal complex which has a coordination number of 4, means the geometry of that complex, it would be square planar. But there are different types of the square planar geometry, that is what we could get depending upon the different type of the complex or the different type of the geometrical isomers. So now let me talk about the first step, and the first step is where we could get a complex where M, that is, it is represents the central metal atom, and in that case, suppose if we are talking about A2 and B2, this A2 and B2 means there will be two similar ligands and there will be another two similar ligands, to which basically this is nothing but N. This N represents the number of charge. It would be positive also, it could be negative also. So based on this type of complex, I'm classifying the different types of geometrical isomers depending upon the different types of metal complex which has a coordination number of 4. So talking about the first step, that is this is the first step, that is what I'm going to talk about. So now let me explain you this with the help of an example. Suppose if the central metal atom, that is nothing but platinum, and here basically I have written here as A2, that means there will be two similar ligands. So in that case, suppose if I am representing, that is there are two similar, that is ligands, that is here it is NH3 and here it is suppose NH3, and there are two similar ligands again, but this B is different from the A. So suppose in this case I am selecting, that is Cl, and here obviously since it is a complex, I am representing with the help of this square bracket over here, and this will have a charge of, that is, since this is nothing but ligand that has -1 charge on it, so therefore I could write it here as +2, just for an instance. So in this case basically I could find, that is, this is one of the form, that is I could write this complex, that is PTNH3 twice and Cl2, but I could write in another form, that is platinum, which is basically present in the central. This is NH3, this is Cl, this is also Cl, and suppose if this is NH3, and overall the charge of this complex, it will be again 2+. But what is the difference between these two? The difference is the spatial arrangement of the ligands. In this case you can find that is the NH3 is present nearby the another NH3, that is they are present adjacent to each other, and here the Cl is also present adjacent to the other Cl. But in this case this NH3 is present opposite to that of the another H3 molecule, and in this case the Cl is present opposite to the another Cl. So that's the reason whenever the two ligands they are adjacent to each other while they are, suppose if they are arranged in a spatial arrangement, so in that case this kind of isomers are basically known as cis isomers, and the one which are opposite to each other, they are known as trans isomers. So this was one of the type where we can find that suppose if the complex is of, that is Ma2B2 type. So in that case I have mentioned an example over here, and this is a cis isomer and this is a trans geometrical isomer. And now let me talk about the next one. So the next type is Ma2BC +1 or minus charge that will be acquired on this complex depending upon it is an anionic complex or depending upon whether it is a cationic complex. So therefore this is what we can find, that is there are two similar ligands and the other two are also different from the A as well as with respect to each other. So based on that, let me give you an example, that is suppose if I am talking about, that is platinum, suppose if platinum is present as the central metal atom, and in that case suppose if this is NH3 and there is another molecule of NH3 that is been surrounding the platinum, and in this case the B part is what I am representing here as bromine, and the C part, suppose if I am representing with the help of, that is Cl. So this is a complex, that is what we have, and this will acquire a 2+ charge on it. But I could write the another form of this formula, and that is I could write platinum, which will be at always, it will be in the central, and in that case suppose if this is NH3, if here also there is NH3, they are opposite to each other, and suppose here it is Cl and here it is Br. So this is the another form of the complex. based on the same molecular formula. So they have the same molecular formula, but you can see that there is difference in the arrangement or the spatial arrangement of the ligands. Here basically you can find that is the NH3 and the NH3, they both are adjacent to each other. And obviously Br and Cl, they both are different from each other, as well as Br is also different with this ligand, that is NH3. But how we can differentiate this two? Means one of them would be cis and one of them it would be trans, but you can see that is this NH3 and this NH3, they both are adjacent to each other, and that's the reason this would be called as a cis isomer. And in this case, this NH3 and this NH3, they are opposite to each other, and that's the reason it is known as trans isomer. And we can also say that is Br and Cl, they are not the same, but the thing, this two similar ligands, based on the position we could find, that is we could call it as cis or trans isomer. So that is the second one, and now let me talk about the third and the fourth type. So the third type that is I'm going to talk about is M, that is nothing but the central metal atom, where ligands are A, B, C and D. So all the ligands are different with respect to each other. And suppose in that case, suppose if I am giving you an example, that is, suppose if I am giving you an example that it is when platinum is present at the centermost, and the ligands are Br, Cl, NH3, and this is pyridine, suppose, as a ligand. So in that case, I could say that is the overall charge of this one, it would be, suppose it is found to be +2. So there would be another formula that is I could write, or another structural formula that is I could write depending upon this formula, and that is platinum will be at the centermost. Here will be Cl, here there will be Br, here there will be pyridine, and here there will be NH3. So even this is possible. But I could write this formula into another structural formula also. That is, suppose if I am saying that is the platinum is present at the centermost, and here there is an attachment of, that is Cl, or I could say suppose it would be Br, and here suppose if it is, that is NH3, there is Cl, and here that is P1. So again, this is the different structure compared to that of the rest of the two, and so therefore these three are isomers of each other. That is, they are the isomers with respect to all the ligands are different compared to that of each other. And now let me talk about the next one. And the next type is M, capital A, capital B, 2. And then this case is, that is, it will have, that is positive charge or the negative charge, n number of positive or n number of negative charge, depending upon whether it is cationic or the anionic complex. Here the capital A and capital B, it represents the chelate, that is ligand, and based on the difference in the position and based on the different arrangement, so therefore here I am going to talk about with the help of an example. Suppose in this case, suppose if I am considering the central metal atom as platinum, and the arrangement of the chelate ligand is in such a way that is I could get here as NH2, I could get here as CH2, this is C double bond O, and here there is O. So here you can find there is an attachment from this side, and suppose if the same group is attached on this side, in that case suppose if I am saying that is, here it is NH2, here it is CH2, here it is C double bond O, and this is O which is approaching here. So this is a complex, that is what we have. But here basically we can find that is the NH2 and the NH2, they both are on the same phase, or they both are adjacent to each other. But what happens if this formula is been converted into, that is this formula, where we can get, that is here, that is there is the presence of NH2, CH2, C double bond O, O. So this is the approached lone pair towards the central metal atom through the nitrogen and through the oxygen. And now in this case, suppose if I am converting, or suppose if I am mentioning the ligand in such a way where here there is an attachment of oxygen, here there is C double bond O, here there is CH2, and here there is NH2. So in this case you can see that this NH2 is opposite to that of this NH2 in terms of a spatial arrangement, and that's it. So therefore these are the two isomers of each other. So this was nothing but a brief detail about the geometrical isomerism in the metal complex with a coordination number of 4. So thank you friends for watching this video. I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.